Hello, how are you?
Great, dude. How about you?
Just fine. Thanks for asking. How's your week been?
Been a great week. Been a great week. Yeah, just it's always a roller coaster. But
Oh yeah.
yeah, just before class on Sunday, I just got back from camping with my friends, and so that was the major event of the last week.
How was that?
It was awesome. A lot of
Yeah.
fun. And, yeah, I baked bread over the fire for the first time in my life, and that was
Wow.
awesome.
I didn't even know you could bake bread if you didn't have a bread making machine. Oh.
Yeah, you can do it with a Dutch oven. So I did it with a
Mm.
Dutch oven, and it was awesome.
Yeah. Where'd you guys go?
Abrams Campground in the
Okay.
Smokies.
Gotcha. Perfect. Smokies. That's awesome. Well, all
Yeah.
right. Uh, you got anything else or should we get started?
Let's get started, man. And I am so sorry about yeah, missing our start time. I yeah, totally messed that up.
That's okay. I just study a little extra. That can't hurt.
Cool beans, man. Cool beans. Well, yeah, let's jump into it. And yeah, if you don't mind, I was also thinking I could share some of the stuff that we go over with some of the other students so they can learn from it as well. Would that be okay with you, or that would that embarrass you?
Oh, it wouldn't be embarrassing. I don't know if my name should be attached to it or not because I feel like a lot of it, I struggled on a bit of it, but I was able to grasp more than I thought I would. Stuff like this standard deviation and matrices uh, are kind of the things that I used to struggle on. But after doing this packet, I got them all right. The ones that I struggled were, um, I don't really know what, hold on a second. I don't really know what they're called, but it's like, if you can see the underlined problem, the n plus, I don't know if it's backwards or not.
Yeah, yeah. Yeah, we can definitely do that one. I wanna maybe save that one for a little bit later because I actually have something else I could give you that might help you with that one. What's the next one that you struggle with?
Let's see, the tangent line circle ones. I can't, the, I can't find the actual problem. Here's the answer. That one. The tangent line
Wait,
circle.
wait. The question, it should tell you what question it is right there.
Number 3 of day 1.
Number 3 of day 1. All right, so 2013 J, number 52. Oops. All right, wait.
Oh wait, I don't know if it's that one. That one is not hard. That one you just kind of have to use the a squared plus b squared is less than c squared, and that will give you your obtuse triangle.
Wait, you said yeah. Well, so we go back and just look at which one it was again.
That number. This one is different than what it says. Wait, which one did we just look at? 20.
I might be looking at the wrong one. Let me pull it up on my phone here. 1 second.
It says here that it's 2016A.
2016A.
Number 52. I might have said the wrong one.
Oh, you're all good. All good. All right, this one right here.
Yes, that is the one.
Cool beans. All right. Well, this one is super easy. Yeah, so I mean, I can teach you this one. The first thing you need to understand is what tangent means. Do you know what tangent means?
It means like if there's a tangent line to the circle, this is how I drew it out. Well, that's a kind of like the lines intersect the outside of the circle at one point. Is that correct?
Well, yeah, it touches but does not cross
Right.
is what tangent means.
Yeah.
Yeah. So we have two rays that touch but do not cross. So they sit right up against the circle.
Mhm.
All right. And so, we know that this is angle A. And we know, one of these rays is B and one of these rays is C. And so, yeah, so we have this.
Okay.
And then it says we connect B and C to form a triangle.
Okay.
So, and then it tells us that the angle A is 70 degrees. So from our picture that we have here, is there anything that we know that might help us be able to answer what the angle of B or C is?
Okay.
Or we're looking for the angle of measure B.
So if we're looking for the angle of measure B, my first thought is that the tangent rays are isosceles, meaning they're equal. So that it would be the 70, there would be two angles with the same measure, which means it would be 55 degrees.
Wait. Yeah, so it'd be 55 degrees, yeah, because it'd be 110 remaining. So you do 180 minus 70 to get 110. And since they're the same, they do have to be the same length because they're both tangent to it, which means they're gonna, it's gonna be the same distance to be tangent on either side. So since they're the same length, you just divide that by 2 and it's 55, correct?
Right. Okay, perfect. For some reason, I didn't understand the quantum ACT prep explanation of it. They started talking, I kind of got confused and lost when they started incorporating the radius of the circle, and they used, rather than a triangle, they had more of a kite shaped thing.
Sure. Yeah, no, it's not always they don't always know the 30-second way on there, but they're
Okay.
pretty good. But yeah, does this make it make sense?
Yes, this is much easier than I thought it would be.
Good. All right, what's next?
Next one that's next. Let's see. Here's another one. The factorials, day 3, number 7. This one was more of a logic. I don't know. I couldn't find a good strategy of how to do it. I feel like I just kind of did it the plug and chug way, which I don't think would be time efficient on the ACT.
Yeah, I just sent you a text. You can ignore it. I just did it so I can open it on here. All right. Which day and which number is it?
Day 3, number 7.
All right. So factorial. How many distinct letter arrangements are possible from the word Farragut? All right. So let's go ahead and work through this. So we first need to know how many letters repeat. So how many repeating letters do we have, and how many of each do we have?
Do they have to be side by side, or can they be spread out throughout the word?
They're going to be spread out throughout the word.
Okay, so we have 2 repeating letters, and they each repeat twice.
Yeah, we have 2 repeating letters, and they each repeat twice. All right. And so then let's just say that we only had 4 letters. Okay. And they were all different. Do you know how to calculate the number of distinct possibilities if we had 4 letters and they were all different?
I don't think so. I can't think of a method off the top of my head.
All right. Well, let's start there then. So go ahead and add this question to your worksheet. Okay. So yeah, let's say we had talk, and I want to know the number of possible rearrangements of the letter. All you do, it's just 4 factorial.
Okay.
That's the total number of rearrangements of that letter. Does that make sense?
Okay. I understand. 4 factorial. Is that like something I can plug into a calculator, or is that
Okay, well, do you know what a factorial is?
not really? That is a very foreign concept to me.
All right. All that it means is just a very simple way of saying that number times every number smaller than it, all the way down to 1. So it's just 4 times 3 times 2 times 1.
Oh, okay.
That's all that the factorial means. Does that make sense?
Yeah, that makes sense.
So yeah, so you're just doing 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, times 1, obviously 24. And so there are 24 possible rearrangements of that letter talk.
Okay.
Does that make sense?
Right. So how does the repeating letters, like if there's 1, 2, 3, 4, 5, if there's 8 letters in Farragut, how does the repeating letters play into it?
All right. I'm gonna walk us through a couple other things first, because you need to know how to do a couple other things before we do that. Okay. So let me just pull up something on here. All right. So tell me what 5 factorial comes out to.
All right. 5 times 4 times 3 times 2 times 1.
All right. I'm just going to, since you got it, I just want to make sure you got that. All right.
Perfect.
So now let's go to number 12.
Okay.
All right. So I want to see if you can figure out how to do number 12.
Without a calculator? All right,
yeah. So I just want you to more so just write it out. So just tell me what to do here.
All right. So it would be the numerator of the fraction would be 6 times 5 times 4 times 3 times 2.
All right, let's stop there. Let's stop there.
Okay.
So, all right. So since you got, because if you just leave it at 6 times 4 times 3 times 6 times 4 times 3, 6 times 4 times 3 factorial.
Right.
Yeah, 6 times 4. Wait, gosh. I don't know why my brain keeps freezing. 6 times 5 times 4 times 3 factorial.
Okay.
That's the exact same thing as 6 factorial. Does that make sense?
That does make sense, yes.
But now we have a factorial on the top in the numerator that is the same as the factorial on the bottom, and they just cancel out.
And then you're left with the answer, which is just 6 times 5 times 4.
Exactly.
Perfect. So you subtract like for the next one, for 13, you would do 7 factorial minus 4 factorial, which would be 3 factorial. So 7 factorial divided by 4 factorial is equal to 3 factorial.
No, don't do that.
Okay, don't do that.
Don't do that.
All right. So it is better to write it out the way we did number 12.
Yes, you have to write it out. You cannot do what you just did. You will not get the same answer. You'll get a wrong answer.
That's good to know before I make a mistake in the future. Okay. So the answer number 12 would be 30 times 4, which is 120.
Wait,
so
where are you getting 30 times 4?
I'm getting the 30 times 4 would be.
Are you talking about 12?
Yeah. I went back to number 12.
Well, let's go to 13.
All right, perfect. Okay, so the answer would be, or the equation would be 7 times 6 times 5 times 4 factorial over 4 factorial. And the 4 factorials cancel out. And then you're left with 6 times 5, which is 42 times 5, which is like 220. I don't know. 40. Yeah, 220, 210 or something.
Yeah. So we don't need to take it that far. I mean, you can do that part with the calculator, but I just want you to get this part. Does that make sense?
That does make sense. Yes.
All right. So now let's go back to our little, problem here. And so since we have 2 repeating, all right, you'll start out with the top of just 8 factorial because that's how many letters there are. Does that make sense?
Okay. Yes.
All right. And you're going to divide that by 2 factorial and 2 factorial.
Divide that by, oh, okay. Because there's 2 sets of repeating letters.
Well, there's 2 sets of 2 repeating letters. So there were 3 A's. We would do 3 factorial times 2 factorial.
Okay.
On the denominator. Does that make sense?
Yeah.
So that is how you solve this. So now walk through what I need to do here.
Okay, so the first thing I would do is write it out 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial all over 2 factorial 2 factorial. Okay, so my first instinct is to cancel out one of the 2 factorials with one of the factorials on the bottom.
Yeah.
Perfect. Okay. And is 2 factorial just 2?
Yeah, it's just 2 times 1. So it's just 2.
So it'd be 8 times 7 times 6 times 5 times 4 times 3, all divided by 2.
Yeah, and I would just go ahead and cancel 1 out now. So you can get rid of that 2. So then you just 4 times 7 times 6 times 5 times 4 times 3. You plug that into your calculator, and that is how many rearrangements are possible of the word Farragut.
Gotcha. Perfect. That makes sense. Okay, that's good. And so disorganized here. There it is. So the factorials in number 11 of day 1, is that can that be done in this can that be done in the same way, even if it's attached to a variable?
Well, it can be done similarly, but I'm going to save this one until last. So we'll save this one until last. So yeah, which one do you have next?
My next one. Okay, number 10 of day 2. And this is another concept that I'm getting better at, but at the beginning of this course, I did not know how to do the matrices. Number 10 on day 2.
Yeah, so I mean, this one really couldn't be any easier. The only thing you're writing it as, they're just wanting you to write it in a different format. But all the augmented matrix is going to do is it's just going to you're going to have this for your equal sign. And then you're going to put, just the things that are there, 2, 1, 4, 3, 5, 20. You're just writing it in that form. It's just writing it in a different format. That's it. That's the augmented matrix.
Okay. So if I have a problem like that on the ECT, but it doesn't give me the 2x plus y in that format, do I put it into that format and then write it like that?
No, they have to give you that format.
Perfect. Okay. So they won't make it more complicated by making me find that format. No,
I mean, they're just going to scare students away because they don't know what an augmented matrix is.
Okay. Right. They make it sound a lot more complicated than it is.
Well, that's always what they're trying to do because this test is so easy. If they didn't do that, then everybody get a great score. So they have to make it sound hard, but they have to choose the easiest math that most students, aren't familiar with. So it's all easy. You just got to learn it.
Okay.
All right. What's next?
The next one is number 11 of day 2. And this one is just another easy one that I didn't really understand the logic of like where's the, they said, okay, that's answered.
All right. So let's make your life easier first. Let's
Right.
go back and do number 15.
Okay.
All right. So do you remember how to do number 15?
Number 15 of what day?
Oh, day one. I'm sorry.
Yeah. I can do number 15. Should I do it now?
Well, just tell me what to do on the screen here.
Okay, the ratio of A to B is 2 to 3. Okay, so I find, okay, so it's hard to explain, but the ratio.
If it's hard to explain, then you don't understand it well enough.
Okay, well then this is how I'll say it. You got to find the common factor or the least common factor of the two of, is it looking for, it's looking for A to C. So you're going to find the common factor of B, and then you're going to multiply the A and C value of the two ratios, and that will give you the ratio between A to C.
Okay. I don't think I'm following, but all right. So tell me what I do here.
Okay. So my first step would be to multiply the A to B ratio by 2 to get B to equal each other on the two ratios.
All right. So what would it be?
So your A would be 4 and your B would be 6.
Okay.
And then now that your B is equal to the B on the other ratio, you can put them together to have 4 or 5. The A to C. Is that incorrect?
No, that's perfect.
Oh, okay. There we go.
Yeah. So now this one is the same thing. So yeah, the net worth of Bill Gates to Mark Zuckerberg is
I think that's number 12.
Oh, what were you asking me for?
Number 11.
My bad. I'm
That's
so
okay.
sorry. I thought you said 12. My bad.
Yeah.
All right. So, okay. So number 11, let me take a look at it here. All right. So, what is a probability?
A probability is a chance of something happening. So like, I guess that's the most simple way I can put it. Just a percentage out of a number.
All right. Well, yes, what you're saying isn't wrong. But when, yes, we are dealing with the math, you can't have something that equals more than 1 for a probability.
Okay, that's where I was confused because I thought that you could have that. It would just be like 120, like 100%, 120% chance of something happening. I thought that's what it meant, which is why I was confused. That's why I said it was E.
Yeah, no. Yes, when you're dealing with probability on the ACT, they will specifically try to trip you up because you cannot have an answer that is greater than something equal to 1 when it's a non-decimal form.
Okay, I see. That's where I got tripped up. Just a terminology thing, I guess. All right, well, let me keep looking. Okay. That one I figured out how to do. That one I figured out how to do. Okay, I could use more. This one took me a long time to figure out just because complex numbers are, well, they're pretty a complex thing to do. So number 11 on day 5 is where I struggled.
Okay, 1 second. I just looked this up just to like give you an exact definition. All right, when you're dealing with probability and algebra,
okay,
it is always greater than or equal to 0 and less than or equal to 1. Always.
Always. Perfect.
Cool.
See.
All right. So what was the next one that you asked?
It was day 5, number 11.
All right. So to do this one, you first need to understand wait, I'm forgetting my give me 1 second. Yeah, I'm gonna cheat 1 second. Let me look at my notes. I don't know why this word is leaving my mind, but it's not there. Conjugate. All right. So you first need to understand what a conjugate is. So
Okay.
the way I'm going to ask you what a conjugate is, just do 3 plus 2x. What is the conjugate of 3 plus 2x?
3 minus 2x.
Yeah, 3 minus 2x. Okay. All right. So what you need to know about complex number questions is that the answer is almost always the conjugate.
Okay.
Because the conjugate is the easiest way to turn the number into a whole number.
Okay.
All right. So when you're dealing with irrational numbers, rather. So if we have, I'll just work this out so you can like actually see it. So 5 plus 3i times 5 minus 3i. So we do 5, 25, minus 15i plus 15i. Minus 9i squared, but 9i squared, it just becomes -1. So it just becomes that. And then those cross out. And so then we're just left with 25 plus 9, which would be 34. So if we multiply this by the conjugate, it will always turn out, if you multiply, an irrational number like that, a polynomial irrational number like that format, by its conjugate, it will always turn into a whole number.
Okay, perfect. That's good to know. I can do that.
All right. What's next?
All right. I think that was it. That was the last one on the hard but easy math packet. I actually haven't done the bonus questions yet, just because I haven't had a lot of time to work on it. And
That's okay.
yeah, I did have to, today is day 4 of my week. It's Thursday. So I did go ahead a day. So I'm actually glad I did that I went ahead and looked at day 5 to see what I struggled on.
Yeah.
But
No,
everything on day 5 was, I thought it was pretty easy.
Well, let's go ahead and I want you to teach me number 12 real quick.
Okay.
Will be great. So go ahead and teach me number 12.
Okay, number 12. This one is actually exactly like the one that my coach sent me to practice on, like the question of the day.
Yeah.
So if you have Q is equal to 10 R 10 to the power of R minus T, and then you're also given that log base 10 of Q is equal to what? So the way I like to think about this is that the exponent of the base equals, okay, so the answer to a logarithm is the exponent you need to get your base equal to the argument of the logarithm. So like you find, if you're given that Q is equal to 10 to the power of R minus T, then the answer of the logarithm is R minus T, because, well, I think that's just a rule that I've always known since like my sophomore year when we learned logarithms.
Yeah. So let's just, work this out. Let's just convert Q equals 10 to the RT to logarithmic form. So
Okay.
what would be our first step if we convert Q is equal to 10 to the RT to logarithmic form?
Okay, so I would put to logarithm form, I would put RT minus or RT R minus T log base 10 of Q. Is that correct?
No. Okay. So let's just walk through it. Okay. So the base is always going to stay the same.
Okay.
So you have a log base 10. So the 10 to the RT is the base 10 of 10 to the RT is the 10 is the base. So
Right.
the base is going to stay the same. So it becomes the base of the log though. All right. And then the answer when it's in exponential form is going to become the log.
Mm-hmm.
So it's log base 10 of Q, and then the exponent becomes the answer. It's going to become what it equals in logarithmic form. So all we're doing is rearranging this stuff. It's super easy. Anybody can do it. But yeah, I mean, maybe that's what you meant and I just didn't understand, but do you understand? Does that make sense?
Yeah. So the rule that I got gives me the right answer. I just didn't know why the rule works, which is what you just taught me, is why the rule works, how to convert it from the equation form to its logarithmic form, which is the skill that I didn't know. What I did know is just how to look at the logarithm and know the answer, which is not always the best thing to do.
Yeah, but I mean, it'll get you there some of the time. But yeah, if you just know these very simple things, it'll get you there the rest of the time. And there is a 1-page logarithm lesson in your math notebook, which doesn't take long to do if you want a little bit more practice converting, logs to exponents and exponents to logs on there. But awesome. All right. So then we'll do that last one now that you've been wanting to know. And so let me just pull up this since it's going to be the same. All right. So you have a basic understanding of how factorials work now.
Mhm.
And so this problem is going to be the same way. When you have if you had n plus 1 factorial and n factorial, all you're ever trying to do is pull something out of either the top or the bottom that's going to equal something on the top or the bottom so that they can cancel out. So if we expanded the numerator here of n plus 1 factorial, what would the next expansion be? It'd be n plus 1 times what?
And so if it's n plus 1 factorial, then it would be n factorial and then n minus 1 factorial. Is that correct?
Well, yes, but you're saying it'd be n plus 1 times n minus 1 factorial. Is that what you're saying?
Yeah. Yes.
Yeah, because that goes on forever. So it just keep going on. But we don't want to go on because we already found one that was in our denominator. So we would want to stop at n factorial because that's in our denominator. And then we can just cancel those out. Does that make sense?
Yes. Yeah, it does.
And then you're just left with that answer being n plus 1. You following me?
I am.
All right. So now we're going to do number 14 on the page on the screen here.
Okay.
And let's see if you can figure it out.
All right. So
try to cancel as many things out on the numerator and denominator as possible. All right, go.
All right. N plus 1. Give me a minute. I'm just writing it out.
You're good.
All right, n minus 3 factorial. Okay, so the first thing I'm going to do is I'm going to write out n factorial n plus 2 times n plus 1 factorial n minus 2 factorial. So then all divided by n plus 1 factorial and n minus 3 factorial. So then you can cancel out the n.
Wait. Okay. Yeah, go ahead and just walk me through because I'm lost on what you're doing right now.
Okay, so
what does your numerator have right now?
My numerator has n factorial, and then it has the n plus 2 times n plus 1 factorial.
Wait,
and
n plus 2, n plus 1 factorial. Okay.
Yeah. And then also it has n minus 2 factorial.
N minus 2 factorial. Okay. And these are all, okay.
Those are all in the numerator. My denominator is n plus 1 factorial and n minus 3 factorial.
N plus 1 factorial and what?
N minus 3 factorial.
N minus 3 factorial. All right. Okay. So, all right. Tell me, let's start with the denominator actually. All right.
Okay.
Tell me how you got this for your denominator.
How I got this? It's in the question.
No. I think you're doing the wrong question then. I'm sorry. We're doing 14 is what I wanted us to be doing.
14. I was doing number 15. Okay. My bad.
Yeah. So, well, I mean, since I've already got this, yeah, well, let's go to 14 just to keep it. Yeah. Go back.
Sorry about that. That's my fault. Okay. So, is that correct for 14? That's what I've got so far.
Wait, I thought you did 15.
I mean, 15 is what I mean. Geez. Is that correct for 15 so far?
I don't know. I already.
That's what I did wrong. I used the numerator of number 14 and the denominator of number 15.
Okay. Gotcha. All right. Well, let's start over and just tell me what you want me to put. Yeah. Go ahead and start over. Work it out on your paper and then tell me what you want me to write.
Okay. So which one do you want me working on right now?
14. We're doing only 14. Numerator Perfect. And denominator from 14.
Okay. So n plus 1 factorial and then n minus 1 factorial divided by n minus 2 factorial. Okay. Well, this one's a lot easier. Well, it's a lot easier when I'm actually having a whole problem instead of parts of 2. Okay, so my first thing is I'm going to have n plus 1 factorial, and then I'm going to have n minus 1 times n minus 2 factorial all over n minus 2 factorial. Is that correct so far?
Yes.
And then I'm going to mark out the 2 n minus 2 factorials, which leaves me with n plus 1 factorial and n minus 1.
That's it.
Is that the end? That's it?
That's it.
Perfect.
Yeah. So this is super easy if you just let it be easy and you just realize it's just going to be one less every time. You're just multiplying it by one less every time, and that's that's like good. So all right, so let's do number 16 now, which I believe is the one that you actually had the question on from the worksheet. Yeah, it's the same. Yep.
All right, so n plus 1 factorial, n plus 1 and minus 1 factorial divided by n factorial squared. Okay, so the first thing that I want to do is I'm going to write out, I'm not going to change anything, but I'm going to do n n plus 1 factorial, n minus 1 factorial on the numerator. And then on the denominator, I'm going to write out n n factorial twice. Like, I'm going to break it up, the square. So then I'm going to get n. Okay, so n plus 1 times n factorial, and then n minus 1 factorial all over n. Okay, then I'm going to cancel out one of those. So it's n plus 1 times n minus 1 factorial over n factorial. Okay, so from here, I can't do anything. I think that's simplified.
No,
Is this
missing one thing.
What?
You're missing one thing, and that's why we put this one on here. It's a little bit trickier, but you can get it, or you can ask for some help.
All right. So one thing. Oh, geez. Okay, so what am I missing? Like, this is where I'm at right now. The circled portion.
Yeah, you're missing one thing here.
That's one.
I can give you a hint if you want a hint.
I'd love a hint if you have it.
So sometimes you have to expand something in the denominator to cancel something in the numerator.
Okay. What can I wait? So, oh, I see now. All right. I see what I'm doing. All right. So n plus 1 n minus 1 factorial. Okay, so it's going to be in
On the numerator or the denominator, where are we?
denominator.
All right.
N minus 1 factorial.
Wait, say it again. So what am I putting in the denominator?
N times n minus 1 factorial.
There we go.
There we go. So, and then we can cancel out the n minus 1 factorial from the denominator as well as the numerator. And that leaves you with n plus 1 over n.
Boom. Well done,
There we go.
dude. Does that make sense now?
That makes a lot more sense. That is very clear.
Good. You did great. You have a very good math mind, and glad